All right, so these are similar to Arduino. This is just a little bit different, more specialized stuff. So we see like a shield here. What you're going to see with a shield is you're going to see a little bit more things are a little bit more fleshed out as compared to the driver. Um, and you're going to have a little bit better just quality and options as far as like the basic functioning as well as the power and stuff like that. So this is a shield right here, and it fits to this is a robotics one, but it's Arduino compatible stuff. And then you can see here, this is just a standard driver. This is actually the cheap one. This is one that comes with all the kits. So what we've got going on here is let's see here. So we've got the connector comes off of here, and then that'll go to this is a stepper motor here, and then let me just turn this on for you. Okay. So, and this is running. I don't have it hooked up yet, but this is running to an Arduino ATmega. The thing is about the driver board. Part of it is the power, the power, and then the interference and fields caused by the actual motors themselves. So sometimes it makes more sense to have your Arduino or your whatever your microcontroller or whatever that is, in addition to its communication components, away from the magnetic fields and interference caused by the motors and the servos and stuff like that, especially when you start operating at like full tilt or heavier, bigger motors and things like that. You can create enough interference, and this is more like of a drone thing, like like something that applies. People apply more with drones and stuff like that. But you can cause enough interference to screw with that radio, signal and stuff like that. And then also some of the sensor apparatus that you might have on the vehicle itself, or the car, the plane, whatever it is. So part of the thing with the driver, as opposed to the shield, is that you can put it away from the microcontroller, and you can hook it up to its own power. So like instead of you see here, we've got AT650 battery bank here. So and this is powering the Arduino ATmega or whatever like that. You could have your own a separate battery here, and you could have something a little bit beefier, like like maybe like a 7.4 volt a lithium ion battery pack or something like that, because you can put with this, this is 5 to 12 volts here, and then on the shield, you've got like heavier connections and stuff like that. Like these are these headers here, where you can tighten the wiring down. You can use thicker gauge wiring, and you can so you could power everything separately, separate battery packs and everything like that, and you can maintain separation. So these are things to consider with your project. I don't think you're gonna have to deal with the interference or anything like that. But it's just going to be a matter of how you set everything up, especially if you're not working from a kit where everything's kind of laid out for you. If you're kind of doing this, design as you go, or like what feels right, whatever like that. You might want to work with the driver as opposed to the shield, and then also like how much do you want to stack, and how do you want that set up. So it's a kind of a judgment call, so the shields are going to be larger. They're going to fit usually right over top of the microcontroller board itself, whereas the driver is going to be a little bit smaller, a little bit more contained, and where you can just run wiring to it. So, but both of them have the ability, you can hook up power for the motors to the driver or the shield. But then there's also the considerations, like I said, of interference and stuff like that. So I hope this helps out. I'll let you go.